Get rid of our recording screen there. Okay, great. Thank you. When Dave asked us to talk about advanced framing, we know that back in the 70s, there was the original oil crisis that kind of prompted using less lumber to save energy back in the day. And now we're kind of revisiting that again. And that was actually codified in the building code. A lot of people don't know about it. So we're going to kind of dive into that a little bit here today. So let me see that. We're having trouble changing slides. Apologize for that. There we go. We've already talked about me and talked about Nick. Get going on. I guess it's lagging just here a little bit. Here's the definition of advanced framing as we see it. We did a project for Edison back in 2014 where we, and we'll get into that a little bit later, where we helped a builder get a tract house to Z&E standards. And one of the things that we implemented as along with other measures is advanced framing. And basically it's a collection of wood framing strategies that reduces the total amount of wood used to construct the building and increase its effective insulation potential while still maintaining the home's structural integrity. And that's a quote from Will Vicent, who we worked together for Edison back on this project. He's now with the CEC, and he's kind of oversees all of Title 24. But then we talked to a lot of builders along the way and framers. I was a framer for many years and carpenter. I tend to consider myself more of a carpenter than just a framer. And that the framers know their stuff and they're used to doing it a certain way, and that feels comfortable. You know how a wall goes together. You know, they look at it and you look on the floor and you see the pieces where they should go, and they cut them and they put them there. It's like a puzzle, and if you leave something out, it just doesn't feel right. It's like looking at a ceiling, a T-bar ceiling with a ceiling tile missing. You just got to put it in there, whether you know that you need it or not. You put it in. But the big picture is, let's take out the lumber you really don't need, replace that lumber with insulation, and make your building more energy efficient. And it'll improve your bottom line, not just efficiency, but the builder, as a builder, will actually save money on the construction. And just as a reminder, the building is a system. There's a lot more to it than just one component. You know, everything works together with synergy, and some things work much better together, like air. We'll get into that too a little bit later, as far as air sealing and insulation and the framing. They're all kind of integrated together. One affects the other. The energy modeling proves that out too. And then the real world energy design rating comes into play with your Title 24. So by removing framing that you don't need, it improves your framing factor, which is or framing ratio. We use those terms kind of interchangeably. That means, like, say if you have a 10% framing factor, that means 10% of the wall is lumber and then 90% is open. So, and then on center is, OC is on center, like you have studs in the wall, vertical framing members, 24 or 16 inches on center, which means every 16 inches you would have a stud there. And we're also going to talk about insulated or super structural insulated panels. We used to call them super insulated buildings when we were building that way, and it works really well. And there's in this photo here on the left, that is actually a picture of what's at Edison's Energy Education Center in Irwindale. And if you ever get a chance to get out there, you got to do it. There's a lot to learn right there. In fact, we're going to be doing a half-day class there on, this is the high performance wall, high performance attic display. This is just half of it in this photo right here. And we show a lot of different combinations of materials and framing methods to meet the energy code. And then we're going to talk a little bit about parts and pieces like the plate, it can be, it's not what you eat off of, it's the bottom horizontal piece. I don't know if you can see my cursor, like over here on the left. That's a sill plate or a bottom plate. Some people call it a mud sill. And a sill can also be at the bottom of a window, like a horizontal piece, like a window sill. And then a trimmer goes alongside of a window, an window or door opening, you know, at the studs or the vertical members. I'll get to an illustration here in a second, but I just wanted to run down this list. There's king studs, which are the ones that hold up the headers that you nail into the headers into. And also, obviously, the header is what holds the weight over an opening. And rafters are up above holding the roofing. And you've got things like fly rafters or barge rafters that are on your gable ends that, and depending on what part of the country you're from, they call them different things. So I one time worked for a custom home builder in Washington State. And like I said, we did every trade. It was a very valuable experience to learn all the trades from the ground up. But they have different lingo there. They call parts and pieces different. And I had to catch on to that. Like floor joists, and you have rim joists, and they can also be called band joists that goes around the floor framing. You got purlins up in the attic that go perpendicular to your rafters, and they use those in truss systems. And you got knee walls or a pony wall, that can be the same thing. It's a shortened wall in an attic situation, like a 1.5 story building. And then you've got soffits and drop ceiling areas, which can be also considered interstitial space, you know, in between floors where you may be running ductwork and things. So here you've got a different, well, not different, but it's a better view with it's just a line drawing, but you can see a lot going on here. You can see the vertical, you got the studs, you got your king studs. Now, if you notice here, you can actually be supported with a hard piece of hardware instead of a trimmer under the header. You also don't see extra cripples under the windowsills. You don't need those. That sill is not going to fall down at the end. You've got nails going through this king stud, which is holding the sill in place. Excuse me. But you've also, I know that the window trims come into play too, depending on how it's going to finish out. Sometimes you may want to add more backing around your windows. And you can do that instead of having straight through framing that conducts heat straight through the wall and cold. You can put backing that's flat ways, turn it 90 degrees. It's a little more work, but it does the job. And you also are stacking a 2-story for advanced framing. You can see you're stacking your ceiling joists, and your next floor studs are right above your floor joists, and then your rafters or your trusses are point loaded right above that. So it takes a little planning. And with the CAD systems now, I'm sure you guys know that you can mark out the plans where every single part goes right on the drawing, so they can easily take care of that in the field. And here's an example of a project that we were involved in, and I just took pictures of the framing because they weren't doing advanced framing. We were doing other things on the job as far as mechanical, and we also did spray foam, closed cell spray foam. But you can see there's a lot of extra lumber around this window framing, and obviously it's not all needed. You can see this electrical box. Whoops, I clicked that back. Electrical box there at the bottom, they cut out 2 of those window sills, the sill pieces, to put their box there. That was actually the countertop height in the kitchen. So that was right above the counter. And then the next frame, you see this is the outside of the same window. And you see that what they did is they had 2x6 walls, and then they used 2x4s to inset the windows just to make it a nice little reveal to, you know, so you just didn't have a plain wall. And when the architect came out and saw that, he says he's going to come up with some other ways to do things like that without having so many thermal shorts, a big area around the opening that's solid lumber. And speaking of thermal shorts, this is an infrared photo of a room addition that I looked at one time, and I thought this would be worth sharing. You can see down in the lower section, this darker part of the wall, the studs show up as warmer and the insulation is cooler with the more of a blue color. But then you got on the ceiling, you got the ceiling joists. They're actually cooler than what should be insulated. Well, what's missing? Obviously, they didn't insulate this room addition in the ceiling at all. But it's interesting to see how the studs are warmer or cooler depending on the insulation around them. And you can also see the metal window frame back here is pretty warm too. The sun was shining on that back wall. And this is just a little bit of review in a sense. We're showing the stacked stud framing. It's not totally 100%. They've got some studs that are off. I found this picture on the internet and I apologize. I lost who the credit goes to for that. But I thought it was just a good educational photo of some framing just to show that it can be done in real life, but then again, it takes a little effort to get it all lined up, but they're using a lot less lumber. But you can see on the first floor, they went ahead and they're using trimmers under these headers and on the second floor. But with advanced framing, there's different levels that you can go to. This one on the right is just showing what is normally done on the interior. But I just wanted to show the trusses, how they were able to expand such large areas. And then you can see the purlins along here running perpendicular to the trusses. Now, let's just go a little bit deeper into this. Take a look at this wall section. And this is another picture I just ran across, and I thought this would be a really good teaching moment just to do a deeper dive. There's a lot of wood here that's not necessary to hold that wall up. So let's take a look here. You see the red circle up there. What's the reason that stud is there? Well, they stopped the top plate right there instead of taking it a little further to where, say, over the king stud that has to be there for sure. It's easier for the framer in the field just to throw a top plate down and wherever it ends, throw another stud in the wall. So that's what happened there. And then over here on the right, you see the W, that's another wall intersection. Well, behind that, we call it a trough or a channel, or some people call it a T-post in some parts of the country. But you have your wall is intersecting right there. And behind it to the outside, there's no place to get that insulated. And then I got a question mark here. Why is that there? We've got several studs just stacked there for, that it's possible they were point loading something up above. Don't know. But if this was a single story building, then that's definitely redundant. And then we got 2x6 right there that we don't need. We've got a beam up above that can actually carry that. If you've got a floor joist system above, you can double that perimeter framing and becomes your beam. So you can totally eliminate the 2x. Well, that's actually a 4x6, but it's the stacked height of a 2x. And then I've got some more X's here. And over here on the left, you can see we've got 24 on center is what they could go with this wall. They've gone 16 on center. And then I've X'd out a lot of the cripples that aren't needed. And then we can even go further than that, like we showed a little bit earlier. We can actually take out the trimmers and install some hardware. A piece of Simpson hardware there will carry that no problem if you were going to keep that header there. But if you're using the beam up above, you don't even need that at all. So this could totally come out and just have a flat 2x6 to frame that opening out. at the top. And it looks a little bit like this. You can see the integrated rim joists up above, and they're using TJIs or some other engineered lumber, it looks like there. And we got a single top. Oh, this actually has a double top plate. You can use a single top plate too. I think they talk about that also. We're going to get into that a little bit. But they've got single sill, window sill. You don't have cripples holding the sill up at both ends because that's nailed to the through the king stud. They are showing 2 king studs here, probably because of the distance of the header span. But you can see the international code references, all these things that we're talking about, and you'll get a set of these slides. You can come back and reference them. I was involved in a project up in Stockton that a friend, George Cortson, and some of you probably know him or know of this project, but he was building homes for Habitat for Humanity, and they did a report for the CEC, and they actually published a book about it, which I thought was great. It's so nice to see it in a book instead of just a report that goes on in a folder in a file somewhere and nobody ever gets to look at it. But you can see, and look at this photo. I thought it was pretty interesting and valuable to do for headers. You leave it, on this one, they left it open and they did the insulation, and then they put a single 2x material, whether it was 8 or whatever the height that they needed for the span. And then they installed that afterwards. They just notched out their framing right here in the wall and then installed it afterwards. And you can see above that, they've got a single top plate, and I've got a better photo coming up of that particular detail. You can see the raised heel truss up above, and they're all stacked right over the framing. So one of the things that we get into with advanced framing, and one of the simplest things even to start with, is to use ladder backing instead of the trough, where you can actually get insulation at the intersections of the walls, and especially the exterior. And in multifamily, it makes sense too, because I know with staggered stud framing, you can insulate between the party walls a lot better. I don't have a photo of that. There's a lot we could do but you'd have to come to the longer class to get into all what's possible. And this is a shot of one of the close-ups of the details we have at the Energy Education Center in Irwindale. And this shows a single top plate using engineered lumber, a 2-stud corner. You can see the hardware on top holding the plates together right there. Hopefully you can see my cursor. And then I'm going to look down here to the left. You see looks like you got a Oreo cookie here with wood, a sandwich header with foam, expanded polystyrene foam. So you got actually an insulated header right there as well. And these are also raised heel trusses. And surveys have shown that there's about a 25% framing factor on most construction. But I don't know if you guys know Rick Chitwood. He's retired now, but he was able to get projects down to the 9 to 11% range of framing factor, which is pretty impressive. And they haven't fallen down, and they're not crooked. You know, you use good lumber, and especially I like engineered lumber myself. I've framed a lot of buildings with structural insulated panels, the SIPS panels. Here's that shot of the detail of the raised heel trusses. You can see that makes it easier to wire too. You got the extra space. And what a great detail that I like, you can see it right here at the point of my cursor. See that black dot? They've got a big screw that goes right up through the single plate, right up into the bottom of the truss. So you're not putting 16 penny toenails on either side of that truss and splitting it out. And with this system, you don't need extra hardware clips either, at least in that particular design. Maybe if you had higher structural needs, you might have to. But you can also see that they've stacked the trusses right over each stud, 2 foot on center. This shows some details and the various ways you can insulate two stud corners, but you also need what's called a drywall clip. And so you need to get your drywallers to cooperate. And it's good to get with all your trades, get them on board before you start a project and say, this is what we want to do, and this is how far we want to take advanced framing. So back when they first came up with advanced framing, we didn't have exterior foam systems. And you might think that, well, we got exterior foam now, so it's not that big a deal to have thermal shorts, but it does make a difference. And Nick will go into that a little bit later on with the Title 24.
Yeah, Ron, I'd just jump in to say many builders would prefer not to build with rigid foam. And so advanced framing is one way to make that work, right?
Yeah, it depends on your, if you're using 2x6 or 2x4. We actually, I know now with code, it's so much easier to meet code with 2x6, but in the education center in Irwindale, we actually show a 2x4 wall frame section that meets code. So it can be done.
You want to review with everyone the difference in conductivity between wood framing and insulation?
Yeah, typically lumber is about R1 per inch, and a 2x4 is 3.5 inches. Let's say you have OSB sheeting on it, so we'll call it 4 inches. So that's basically R4 right there where your framing is. But in the wall next to it, you can have a full 19, or depending if you're using spray foam or fiberglass, you can get a lot more insulation. So if you can, every stud that you can reduce becomes insulation in your wall, and it does add up and it makes a difference. So we got a pop quiz for you here too. We got what's the average framing factor of new homes, and we did talk about some of this, and you can do it incrementally. We talked about getting down to 10, 11%. Well, SIP's walls are actually down in the 5% range, which is amazing, and they're about 3 times stronger than stick frame and about twice as energy efficient. So the average factor is about 25 to 26 on all new construction, new homes. And that's a fourth of the wall that only has like a fourth of the insulation. You can get a lot more insulation in the cavities than where you've got lumber. Here's another picture of the display. I got a close up here showing some engineered lumber being used as rafters, and with the sealed attic and we're showing different types of roofing too, with the reflective roofs, the cool roof. You can actually have dark roofs that are cool roof. So even though I know this is advanced framing, there's a lot of envelope issues that kind of go right along with it. So here's the picture of the 2x4 wall that I mentioned earlier. It's got the single king stud with the metal clips. Unfortunately, we can't get away from, if we've got a metal clip, it's kind of tough to get that thermal short out of there, but everything's got a little bit of a drawback. But you can all look up above, you can see this is a insulated attic, so that becomes conditioned space. And it's only maybe 7 to 10 degrees different temperature than inside of the house without having to condition that space. So that's pretty amazing. This particular one, we use closed cell foam, but we have other examples there in the center that we use open cell foam. And then we also has foam on the outside there. That's our Insulspan, I think it's called. I'll have to look that up, but it's R8 for 1 inch of insulation of rigid. Here's this is a study that I referred to a little bit earlier. This is one we did in Ontario, California in 2013, 14, 1,860 square feet. Edison had us work with the framing contractor. Well, we worked with the general, but I actually went out there and trained the framing contractor to do as much advanced framing as they felt comfortable with, and would still meet their structural code. And he was a little bit uh, apprehensive at first and kind of drug his feet a little bit. It was kind of the old, well, we've always done it this way thing. But by the time we were finished, he goes, Ron, I saved 80 studs on this one house. Well, it's not just the 80 studs, it's all the cripples and things. I mean, it adds up to 80 studs, but that's a lot of cutting and a lot of installing that they saved. And I did a little calculation at today's lumber prices. And if that was just nailing studs in the wall, which it wasn't, there's probably more nails than that, but that was 480 nails for those 80 studs. And I had to come up with a guesstimate of the labor. It's almost 4 hours of labor savings, most likely, and just about $800 savings on one house just for that. And this isn't a 100% scientific study, but it's pretty close, because he was counting those studs. And I backed it up. I walked around and counted the studs in the houses next door, the same floor plans, and then I counted what they did in this house, and he was right.
Excuse me, Ron.
Yes, sir.
Dave Entner makes a point in the chat that, and this house is a perfect example, that you can better accomplish these techniques maybe with simpler building geometry.
Yes, right. And that also speaks to solar too, because when the roofs are all cut up, it's hard to get a decent amount of solar on the roof. I know we got used to all those really cool designs that are super cut up. They look great, but they're not quite as amenable to some of these other features. It just makes it a little more expensive, a little harder to build. But we did use the advanced framing with the ladder backing. You saw that picture. They had the reddish lumber that was treated for pests and for fireproofing. So that whole track had all that. The lumber was all treated, and they used the drywall clips and everything. And we get into a little bit what I mentioned earlier, the blower door testing to prove out how tight the house really is. And this is a project we did in San Bernardino, and we tested those buildings. I just grabbed those photos just so you can see the inside and outside of a blower door test under construction there. Now in talking about air sealing, it's really important, but hard to implement in the field. Now you can see on this photo on the right, you see this looks like brown tape next to that treated lumber. It's going to get, when that wall gets stood up, that brown tape's going to be underneath the wall. And you see that there's some moisture there, some water puddling up right there. Well, obviously the slab is deeper, it's got a dip in it right there, and they didn't double up the tape or anything. So most likely that's not going to get air sealed when that is completed. So just kind of pointing out different things in the field. And you can see on the left, conditions aren't perfect for putting walls up. They've got walls laying every which way, and it's a struggle to get them all up and straight, and it's a lot of work. And then to get them all air sealed, we've added that complication to this process as of the last few years. So, but obviously it's very important. So that's why we emphasize that. This is another project that we were working on for us, and we're using foam. This is open cell foam. The photo on the left is actually above a garage, but you can see they're using a lot of engineered lumber. They can do large spans with less wood. And over here on the right, it's kind of interesting how they sprayed the outside walls, and they use these steel grates to kind of keep the foam from expanding too far, and then they come back and shave off the excess down flat so the drywall doesn't bulge. That makes a very tight house. And as far as making it even more efficient, there's no extra labor to use the radiant barrier roof sheeting if you're not using SIP panels or something like that. You can buy this roof sheeting with the foil laminated on, so there's no extra labor. It actually helps keep the attic cooler. So then if your ductwork doesn't have to, you don't lose as much heat, and your system doesn't have to work as hard, especially in our hot summers. And here's a shot of actually Nick's house being built with SIPs. And I don't know if you want to talk to that just a little bit, Nick.
Yeah, sure. We did it, you know, we're climate zone 6, we're Long Beach, pretty benign climate zone, not like Ontario that you just showed. But we use SIPS panels for speed of construction, you know, and because lumber was really expensive at the time we built this ADU above my garage, and they went up floor, walls, and roof in 7 days and provided for a nice way to vault the ceiling, because those SIPS ceilings can span a long way, and that way no attic was needed for this ADU, which really makes the space feel a little bit larger. So we were really happy with the process. It does take additional upfront planning, though, to go from architectural plans to shop drawings, because all these panels are pre-cut in a factory and sent ready to assemble. So it's a different way of doing things, but I figure if I'd done 2 or 3 projects, I would have gotten to where the efficiency of assembly would make them cheaper than stick framing.
Right. Yeah, I can tell you, I was actually building a lot of these in the Pacific Northwest, and my subcontractors, my drywallers and my cabinet maker, they were actually charging me less money because there was so much less waste for the drywall, for the exterior walls anyway, and time. They didn't have to worry about cutting their drywall at a stud. And then the walls were so straight, the cabinets, they just screwed them in, and they didn't have to look for backing. So that's really not, we're not making an advertisement for SIPs, but that's just my experience. So now we could talk to the energy code, Title 24, and advanced framing actually helps with Title 24. And I think Nick's going to go right on into that with the code issues.
Thanks, Ron. I learned so much watching that first part. That was awesome. I got to spend some more time with you in the field. But Ron asked me to cover the energy side of all of these innovations, and how much energy can it save in your projects, and how much can it help energy code compliance. We all know that those energy code compliance points are really valuable, and even if it's only 1 EDR point or less than that on a new construction project, that can save you having to upgrade to a 16 SEER condenser or any number of things. It can facilitate added glass in your design. So these really are important and worth money. And our modeling software is really feature rich. It can model many of the techniques that Ron just covered with us, including advanced wall framing, high performance walls where we've got insulation in the cavity as well as continuous insulation outside the cavity, high performance attics where we've got insulation at the ceiling and under the roof deck, even semi-conditioned attics where we've got insulation under the roof deck only, because now the ceiling insulation in an unvented attic is less necessary. And alternative means of construction, including SIPs, insulating concrete forms, ICFs, and other alternate envelope systems. Really, the energy code's agnostic with how we meet our U factor, our conductivity of our building envelope, in a way to encourage innovation. They don't want us stuck in one way of building. Also raised heel trusses and enhanced air leakage, which is tested with the blower door test, which Ron showed a few slides back. So next slide, Ron, let's show them how much we can save. Okay, let's start with advanced wall framing. What we did was we took a typical two-story, 2,700 square foot home in climate zone 10, where there's a lot of weather, um, to make these have a big impact. And we wanted to show you on the right side of the screen, this is the modeling software, and you can see we've chosen on the bottom right of the definition of the window, instead of normal 2x4 16-inch on center or 2x6 16-inch on center, we've gone all the way down that menu to 2x6 advanced wall framing. And we've got R21 in the cavity. What that does is inside the software under the hood, it reduces the framing factor from 25% for 16-inch on center to 17% for advanced wall framing. So you see, we're taking credit for less of that envelope being short-circuited, thermally broken with framing. And on the left side of the screen, you see the impact of that change. First, we show the 2x6 standard 16-inch on center R21 walls with a U factor 0.069. Look at the efficiency EDR metric here, 0.7. So in this case, our proposed building complies by 0.7 EDR points, even before we put advanced framing in. But what we care about is how much did advanced framing help us? So when we add that advanced framing, the U factor instantly drops a lot to 0.061, and our efficiency EDR margin opens up to 0.9. So we got a 0.2 EDR compliance boost from that advanced wall framing decision. And you might work with your energy consultants, especially in more extreme climate zones, and ask them to model this. Of course, that'll require you to follow the guidelines within the Title 24 documentation to qualify for that advanced wall framing credit. Next slide, Ron. The next thing we modeled was high performance walls. These are prescriptive standard for new construction already all across the state. So you're probably very familiar with working with these already. But we just wanted to show you that the software is capable of modeling different cavity and exterior continuous insulation combinations. And here we've got standard 2x6 16-inch on center R21 with R4 rigid outside the studs and 3-coat stucco. That has a U factor of 0.051, which many of you will realize is prescriptive standard for new construction all across California, except climate zones 6 and 7, which have an easier bar to clear. But look at the compliance impact of that high performance wall, which has an efficiency EDR compliance margin of 1.7 versus standard 2x6 R21 without the continuous insulation. That's only down at 0.7. So we got a full 1.0 EDR compliance boost in climate zone 10 for adding that continuous insulation outside the studs. So it's a big boost to compliance. Yes, you can comply without it in some cases, but it's really valuable, and encourage you to work with your energy consultants to determine which projects that's a good idea for. Many of them will be a good idea, cost effective to do so. Next, Ron, let's look at attics. I find the high performance attics have an even bigger impact in most of the climate zones that I work in. And in CBEC software, we define two separate assemblies for a high performance attic. We first define what's at the ceiling. Here you see in this example, we've got R38 at the ceiling. And then we're going to have an attic assembly where we define what's up at the roof deck. In this case, we've got roof tile, 10 pounds per square foot, and R19 under the roof deck with thick insulation covering the roof rafters. You see that box is checked. And look at the compliance boost from this change. We went from minus 3.6 efficiency EDR compliance margin with just R38 at the ceiling to 0.7, so a 4.3 EDR point swing for going from a standard ceiling only insulation to a high performance attic. This is among the most impactful efficiency upgrades that you can do. Next slide, Ron. Just got a few more of these. Raised heel trusses also can be modeled in the software. Although before Ron asked me to do it, I didn't even know where to go in the software. That's how uncommon they are, at least in my practice. But you can see down here, there's a box to check, raised heel truss. You put in the raised heel truss height. And in this case, it got us another 0.2 EDR boost to use that. And that's a relatively simple one.
Yep, every little bit helps. They all add up.
Exactly. That's the, you jumped ahead to my
Oh,
punchline.
sorry.
Put these little 0.2s and 1.0s together, and pretty soon it's a serious compliance impact. And if you're gonna look into building this way, you might as well have your energy consultant work with you on what that impact is. Get it in the energy model, get credit for it. Next, Ron. Oh, here we are, SIPs. I also wanted to show you alternate building assemblies are supported in the software. This was actually the ADU that we built. So we used a SIPs wall, 6.5 inches deep, R23 continuous insulation in between the OSB. And you could see the impact of that plus the R38 SIPs roof as compared to standard R21 walls and R31 attic with insulation at the ceiling was, what is that, 6.2 EDR points. Really moved the needle in the case of this project in climate zone 10.
Yeah, and Nick, what I've seen in the field, what really doesn't come through on the software is when you're using SIPs or foam insulation, especially in a SIP wall, it might be actually rated 23, but performance-wise, it performs so much higher than that. And as far as the sound quality, and the air tightness, it really outshines fiberglass.
Yeah, and virtually all of that insulation's continuous in a SIPS
Right.
wall. Yeah. Also wanted to show you ICFs. I don't know how many of you have ever built with ICFs, but did you show a picture of that, Ron?
I don't. You
Okay.
might have had it at your intro slide. We don't have a specific slide for that on this short presentation.
Yeah, well,
Sorry.
think of EPS foam forms with an open interior core that takes concrete. So you've got a continuous layer of foam on the inside and outside and a continuous thermal mass core of concrete. So these can perform really well too, and we can model them in the software. Here you see a 6-inch concrete core with R10 on either side of it. It's a pretty common ICF assembly that I model. And this had a 7.7 EDR compliance boost, even more than SIPs. That's the impact of the thermal mass in addition to the continuous insulation.
Yeah, getting the thermal mass inside the building envelope is huge. I guess an easy way to maybe picture an ICF is like a concrete block in reverse. Instead, when you see a normal concrete block with the holes in it, an ICF, the block part is foam and the cell part inside is concrete. And they're big. They're big. They might be 3 feet long and a foot or two high.
Yeah.
And they're big.
And there's even other alternate assemblies. One manufacturer, Bamcor, recently got an alternate assembly approved by the California Energy Commission called a dual panel hollow wall system. In this system, they've got bamboo on the exterior surfaces of the building envelope, and they're blowing in continuous insulation in between it. So there's very few interruptions of that thermal boundary whatsoever. So that system has a U factor of 0.045, which is even better than a 2x6 R21 plus R5, which is prescriptive standard 0.051. And in in a tighter, less thick wall assembly. So it really performs and has a 6.7% framing factor. Also straw bale, rammed earth, all these things are modelable. There are limits. We can't model everything. But we just wanted to show you that these things are supported by and large with the energy code. Hey, Ron, Dave has a question in the chat for you. Are these things doable with light commercial and multifamily type 5 construction? Are there limits?
Yeah, actually, I built a church with SIPs, built some dormitories. There's been a lot of cold. They do a lot of cold storage with them. You know, you can get a 2-hour fire rating with adding sheetrock. So yeah, they're totally doable.
Yeah, and then Philip asked, can you define what a raised heel truss is and why it improves compliance?
Yeah, raised heel truss is basically, it's a standard truss. You saw how where the truss comes down to the wall, you can't get full insulation out at the extremity of the wall because it's getting narrower and narrower because of the roof slope. So typically they'll have that heel a foot high, so your insulation is full thickness on the floor of the attic all the way out to the outside of the wall. That's why that gives you that additional energy plus for your energy credit.
Yeah, I happen to know if you don't check that raised heel truss box, the software automatically derates the edge of your attic because it knows you can't fit the full thickness in there.
And it becomes even more pronounced in low slope roofs. So you might be 4 foot all the way around the house. You know, if you have full hip roofs everywhere, you might have a 4 foot section all the way around. That could be a large portion of the house that's maybe a third of the insulation or half of what you're going for.
Here's the last one we wanted to show you. Here's the enhanced air leakage as measured by a blower door HERS test. We've set it, instead of the default 5 ACH at 50, we set it to 1. So that's a greatly reduced amount of air leakage. And you can see in this climate zone 10 example, it moved us 0.2 EDR points. So I think we showed you 3 different things that each can add up to 0.2. Put them together and you're moving serious energy.
Mm-hmm.
Next slide. I think I just got one summary slide, Ron. So here's the compliance energy impact of those various measures we just showed you. Some serious energy moving in your favor in these examples. Software supports it. The picture on the right there is an aerosol method of air sealing where you spray it in the house during rough-in and it seals all the little holes, and you can keep spraying until you get to the ACH 50 target you're looking for.
Yeah, and might mention that you use that in conjunction with the blower door. So the blower door creates a negative pressure in that, and so it tries to pull that out through the cracks in the house, every little teeny crack, and then it slowly fills in those cracks.
Right.
It's kind of a cool technology.
Before I pass it to you, Ron, Dave had one more point in the chat, which is a good one to note. One drawback of ICFs is there's a lot of concrete in there, and we've got to start thinking more about embodied carbon, not just operational carbon of our buildings. So with that, that's the energy color commentary to your material, Ron. Thank you.
Thanks, Nick. That really rounds it out. It really makes a lot of sense to what we talk about with this, you know, the sticks and the nails. You know, you bring in the energy aspect of it and how it all ties together and makes a difference. But I just wanted to reiterate that advanced framing, you know, it might sound complicated, but it's not. It's really not. You can start with little baby steps, and depending how far you want to take it, You start with just one thing, maybe ladder backing or something, but I would recommend a few more things than that as a start. But uh, everything you do, as you notice throughout the presentation, each thing affects other things and they all work together in synergy. And try and get your team on board, the builders, the subs, and the guys in the field doing the work. They need to really know why they're doing it, not just that they have to put this thing here or not put it there. Let them know why, why it makes sense, and then probably be a lot easier to get the buy-in and get them doing it when you're not actually there watching. So, and then builders and owners reap the rewards of all these processes. So just something to take away for each of you, just think about the lessons learned today. You've probably heard something new that you didn't know before. Hopefully that was the goal. And how can you implement advanced framing in what you're doing? And one step or many, how far can you go with it? And like I mentioned earlier, just educate and coordinate. It's important, not just with this, but as you know, in construction with with everybody involved. But just, and if there's any questions, we definitely can take those questions if there's any time. If we have time, it's up to Christine's the boss here.
Thanks, Ron and Nick. We've got about five minutes of everyone's time. If anyone has any questions, you can feel free to unmute yourself and ask any questions, or put it in the chat. We'll just hang on for a few more minutes. If anyone has any questions, again, the attendance link is in the chat. Please use that link so that your attendance is recorded. And we'll hang on for a few more minutes in case anybody wants to unmute and has any questions.
Hey, this is Dave. So I guess my question, Ron and Nick, maybe you could speak from an architect's perspective. What do you see as the most effective way to engage other stakeholders? As designers, we might consider the framing to be the purview of the builder, and maybe there's some hesitation to kind of push them in a direction. So what are effective ways to kind of engage in those conversations, incorporate it into the plans? What approaches have you seen in the past that are effective in that way from a designer's perspective?
Well, one thing that I found on some projects that we've done, even just recently, we brought the general contractor to the education center with the display, the smart home and the high performance wall and attic. And they brought all their subs in, and we spent a couple hours with them going through all the kind of what we did with you right now, and answered any questions that the subs had before they started a project. And that was very helpful. That way they're all on board. They know why the builder wants to do what he's doing. And another thing is to bring the owner in there. If you can't get them to that education center, which is an awesome prop, by the way, if you can't get them there, at least get them educated on the principles of these things, and then try and then if the owner of the project, the biggest stakeholders are interested, then it's a lot easier to get those that they are hiring to do it, rather than say one of the subcontractors is all on board, but not the owner or the designer. So, you got to kind of start from the top down. If you get buy-in there, then I think you're gonna have a successful project.
I'd add that I haven't done any construction projects where I didn't push uphill with my construction crew. And you're right, it isn't a comfortable role. But I've found each time they get kind of bored of the standard thing, and they like learning new things. And even though they may not raise their hand and volunteer to be told what to do and do things differently, it wasn't as painful as you might have guessed. And I'm talking about building with rigid foam walls and SIPS panels and real departures from the way crews typically do things, especially at times where they're all busy and like now. But you have to. And maybe getting Ron out to the job site is on one house, you know, might be a good step to take.
Yeah.
I went ahead and put in the chat, the American Plywood Association has some great resources. They've got some
Yeah.
guides and some downloadable CAD details. So that could be a good resource for firms to use, particularly if they want to develop details in their plans.
Yeah, that's great.
Any other questions for today? Again, feel free to unmute yourself if you have a question. Okay, well, it's 12:59. You get 1 day, 1 minute back in your day.
Woohoo!
Thank you, everyone. We did record this program and we'll make that available. And Ron, your slides, if it's okay to share your slides with.
Sure. Yeah.
Okay, great. Okay, well, thank you, everyone, for attending. Thank you, Orange County and chapter of AIA and Southern California Edison. We appreciate the partnership on these programs. Have a great day. Thank you.
Thank you.
Thanks all.
Thank you, everybody.